Hey, so today I have something big to show you. Something I've been working on for quite a while now. And it's named Goliath. But before that, here a quick ad from video sponsor. Big thanks to JLCPCB for sponsoring this video. Hey, you! Do you need high quality and high precision PCBs for your next project? But you don't want to pay so much money on expensive PCBs? Then JLCPCB is your way to go. Visit jlcpcb.com or use my link jlcpcb/ilg. It will cost you nothing extra but supports me. On the homepage you can choose from many services, even 3D printing is now available. For PCBs just click Insert Quote. Here you just drag and drop your driver file and it's done. I mean, how easy is that? Of course you can choose from many options like the material, the color or even 2, 4 or 6 layer PCBs. Also, it's possible to choose between 1 and 2 ounces of copper on the PCB. But that's not all. You can also choose an SMT assembly and they will send you your PCB already assembled home. Or you choose an SMT stencil to make your own PCB. And you know what's the best? You can already get 5 PCBs for $2. Can you believe that? Yeah, but it's true. I've been JLCB customer for many years now and from day one I was in love. The PCBs are super high quality and the precision is insane. I use them in a lot of private projects and on YouTube. So let's not waste any more time, go to JLCPCB and get your first PCBs directly after this video. All the links are in the video description. I've been working with 3D printers for a long time now and over the years I have accumulated more and more feature requests that unfortunately none of the printers was able to fulfill. However, it wasn't even possible to add them later on just because of the hardware limitation of the printers. So I thought to myself, let's make your own 3D printer control PCB. At first I had to think about the software and here Marlin was the first choice. It's a free software that's especially made for 3D printers, laser cutters and CNC machines. Also, it's completely modifiable. You will find the link to the website in the video description. Next I had to think about the hardware and here I chose an ATmega 2560, which you can also find on Arduino Megas, and this chip is actually perfect because of its large number of pins and Marlin is programmed especially for this chip. And here is where I cheated a little bit. If you're into 3D printing and you're from the old days when you had to build your printer yourself and the A-Net A8 were the most popular homemade 3D printers, you definitely heard about RepRap. And RepRap Arduino Mega Pololu Shields 1.4 or short RAMS 1.4. If you don't know what I'm talking about right now, this is a RAMS 1.4. It's a PCB you simply plug onto your Arduino Mega and it helps you to control all the electronics of the 3D printer. You simply connect them to the shield right here, like the stepper motor drivers or the heaters. But what has this to do with cheating? Marlin, like I said, is especially made for homemade 3D printers, which are controlled by RAMs. So most of the important pins are already programmed into Marlin, what means I can save a lot of time programming by just copying a little bit of the RAMs. But to my defense, that's something a lot of people do. For example, this 3D printer control board right here, made by a popular company, has also 5 stepper motor drivers and all in all, similar components as the RAMs. And if you own a 3D printer, open it up and have a look at the PCB. It's probably the same situation. So I mean, I can't prove that they are copying, but seems kinda sus. Now with the choice of the chip and the software, I had to decide what the Goliath should be able to do. And for that, take a seat, it's a long list. The Goliath should have 3 servos, an SD card reader, a display, a serial communication via USB, and stops in all directions, 3 controllable fans, an I2C communication, 4 heaters, a UART communication, 5 temperature sensors, an ISP communication, auto bath leveling, filament runout sensors, a Wi-Fi function, a camera, and 9 stepper motor drivers. 6 of them are normal and 3 of them are smoothable. With that list, I started prototyping. I began by modifying the code so all the 9 stepper motors can be driven. For that I built a little circuit based on an A4988 stepper motor driver that then connects to the pins that control the stepper motor driver to control the stepper motor, as you can see in this picture right here. And it worked! Next were the filament runout sensors. And here I had a clever idea. Originally I wanted to make 6 filament runout sensors, but that would use a lot of pins. So I had the idea to make only one pin for the filament runout sensor and create a special circuit. To understand this, there are different types of filament runout sensors. I chose a physical one. You can imagine it like this little button right here. The filament goes through the sensor and triggers the button. So the button state is read by the Goliath. When now the filament spool is empty and the last bit of filament runs through the sensor, then the button isn't triggered. And so the state is open or closed, depends on the button you chose. And so the Goliath says, oh okay, there is no more filament, I pause the print. This gives me time to fill in new filament to continue printing without having a failure. And here I had a special idea. So my idea here was to connect the filament runout sensors in series and to each sensor switch in parallel. So for example, I want to use filament runout sensor 1 and 3. I simply go ahead and close the switches on 2 and 4, and now these switches seem close to the Goliath because the current just passes through them. And when the filament on filament runout sensor 1 or filament runout sensor 4 runs out, the button isn't pressed anymore and the whole circuit stops. The current can't flow anymore and the Goliath says, okay, I have to stop. Next I had to make the control circuit for the fans, and here I made a simple circuit based on a TIP120 in combination with a diode and a resistor. The TIP120 then connects to a PWM pin of the Arduino to control the fan. It's a really simple principle. Next is one of my favorite features of the Goliath, the Wi-Fi connection. For that I chose an ESP32S cam. But why? One, this chip is able to control a camera, and second, it has this little connector pin at top right here, where you can connect an even bigger Wi-Fi antenna for an even stronger signal. This chip runs a software called ESP3D, written by Luke. You find his GitHub in the video description. ESP3D is especially made for controlling your 3D printer even if you're not in the same room. But here's one important thing. If you want to use the camera feature of the ESP32S cam, you have to choose ESP3D 3.0. Here you set it up and then you get this nice camera picture. If you have problems with ESP3D, there's a Discord with a really active community and I'm sure they will help you out. Last but not least, I wanted to make my own boot screen that consists of the Goliath logo, the Geissler logo, the ESP3D logo and the Martin logo. The results look like that. So now that the code works just fine, I started creating circuit diagrams and designing the PCB. For both tasks I used ECEDA because of their cooperation with LCSC and JLCPCB. If I don't have a component on hand, I simply search for it on LCSC, copy the code into ECEDA and get the footprint, the 3D model and the symbol. When I'm done, I simply export a BOM, which I then can upload to lcsc.com and get all my components. Furthermore, I can directly purchase the PCBs by JLCPCB.com. If you want to support me, take my link jlcpcb.com/ilg. It costs you nothing more, but helps me a lot. So after 1 week, I got this in my mail. This is the Goliath V1.0S and I love it. It looks awesome, it's really high quality. JLCPCB, as always, has done a great job. But that's not all, I also got an SMT stencil. This is a laser cut piece of metal that is made for your PCB. You simply open it up, put the PCB on it, and then fold it down again. And then you can apply the solder paste onto here and simply scratch over it with a spatula for example, and you have a perfect layer of solder paste on your PCB. Here a picture of that. I mean, look at how clean that looks. So if you're purchasing from JLCPCB and you use SMD components, definitely get one of these, because it makes life a lot easier and it's just like $7 or so. Promise me, this is a good choice. But the Goliath is the star of this show, so let's talk about it. As I said, this is the Goliath V1.0S, and for tests I first assembled the main circuit, so the circuit of the ATmega2560, which you can see right here. And what should I say, long story short, yeah, that was unfortunate. However, I made a new one and here we got the Goliath V1.1S and I love it. So let's have a close look at it. So here it is, the Goliath. First things first, the circuit of the ATmega2560 and the USB serial communication as well as the ESP32S are not on this board because I soldered them on another one of these for testing purposes. So let's start with the stepper motor drivers. As already mentioned, there are 9 of them. Here you can see an example, it's an A4988 and they just get plugged onto the PCB. As you can see, every motor driver has 2 terminals to connect a motor. That's because sometimes you need 2 motors, like in an A-Net A8, to drive the Z-axis. So I thought, let's include 2 terminals for every driver. Also, I mentioned that 3 of these motors are smoothable, that you can see right here. 9 diodes per motor, and to disable this function you just flip the switch. Now it's smoothed and now it's unsmoothed. Next is a little feature I really like. Every stepper motor driver has 3 pins to set the accuracy, and on PCBs like the RAMs, you can see right here, you have to connect these pins by putting on a jumper. But I don't like this solution, so I included these little switches under every stepper motor driver with 3 switches per unit, and you just can flip them on and off to set the accuracy. Next are the fans. They get connected right here. Here's the 3 TIP120. The fans get plugged into here. It's nothing special. Here we got the 5 temperature sensors, as well as the end stops for all the axes, the 3 servos, and the filament runout sensor. It's nothing special, you just plug them in and you're good to go. Here we got the terminal for the I2C communication, and here we got the terminal for the RX and TX communication. And this little knob down here is for the Wi-Fi connection, because as I already mentioned, you can connect another antenna to the ESP32S, and that's an antenna like that. You just screw it onto this little knob right here, and then you have a stronger Wi-Fi signal. Over here you can see the terminal for the mains voltage. You can just unplug it and plug it in again, and the voltage gets connected 12 volts ground, 12 volts and ground, which then get into these yellow fuses to protect the board. The 12 volts then go into this DC to DC step down converter based on an LM7805 that converted to 5 volts. After that, the 5 volts get into here. That's another DC to DC step down converter based on an AMS1117, and this converts it from 5 volts to 3.3 volts, which are needed for the ESP and the camera. To make sure that all the voltage levels are working properly, I got this little unit right here with an LED for 12 volts, 5 volts and 3.3 volts, and if everything works properly, a daylight green. Here you can see the connection for the SD card reader and the display. You just plug it in and you're good to go. So now some of you may have noticed that there is something really important missing on this PCB. It's the heaters. But for that, I chose to make another PCB. This is the Goliath heater PCB. But why did I do that? It's really simple. To heat a heat bed or a nozzle you need a lot of current, and to handle this current you need really thick roots. But unfortunately I couldn't fit them onto the PCB right here without making it too big, so I decided to put it on an extra PCB. Also, if one of these MOSFETs break or there is a short circuit between one of these roots, I can simply change this PCB and don't have to change the whole Goliath. But now you may ask yourself, how do I connect this? And that's really simple. Here you just connect this little ribbon cable onto this and a terminal in here, like for the mains voltage. Then you connect the little ribbon cable to here and the terminal to the terminal right next to the mains voltage, like that. Now the heater PCB gets 12 volt through this terminal right here and the signal through the ribbon cable. I also included 4 LEDs right here and here, and they indicate if the heater is turned on or not. So you can make sure if your heater is broken or it's just not turned on. Here you see a little video of the LEDs blinking. They actually should be purple, but they turned out more bluish. Now the question is, does it work? And to be honest, the first problem was the serial communication circuit based on an ATmega 8U2 that didn't work at all, and I don't know why. I took the circuit diagrams from the original Arduino Mega circuit diagram, so it should work, but unfortunately it doesn't, and I can't find the mistake. The second is the circuit of the ATmega 2560. I took the circuit diagram plans original from the circuit diagram of the Arduino Mega, and it used to work, but then suddenly stopped working. Here I got a video of the LED blinking, so it was doing something. Unfortunately, I made a video on how to create your own Arduino Mega, so I should know how to use this chip, but I relied on other plans and not on my own, so that's kind of my own mistake. The next thing is the voltage regulation. On the Goliath there are 3 voltage levels, the 12 volt, 5 volts and 3.3 volts, and they used to work as well. As you can see here, all the status LEDs are lighting green, but then they stopped working and I can't find the mistake either, so I don't know what's the problem right here. And when the voltage isn't working, the whole Goliath is a failure. All in all, the Goliath was really fun to develop, and one day I want to get it running too, but for now it sits on my shelf waiting for its return. Maybe I should first build the smallest instead of the biggest 3D printer control PCB. We will see. But that's it for this video. I hope you liked it. If so, feel free to like, share and subscribe. Here are videos, here find my channel, so have a nice day and see you soon.